So hello guys, have you ever had ice cream on a hot day before? Delicious and refreshing, isn't it? But can you tell me what happens if the ice cream was to remain outside under the sun for some time? Of course it would melt. But what happens if you left this ice cream in your refrigerator? The ice cream definitely wouldn't melt in a working refrigerator. The ice cream melted because of the heat, obviously. It is not only ice cream that melts in the heat, candles do so as well. And have you ever seen palm oil on a cold day? It's almost solid. What you begin to notice about all these substances is that they change their nature due to the surrounding temperature. As it gets hotter, they become more liquid, and as it gets cooler, they become more solid. It is not only ice cream and candles that go through these changes. Everything that is matter is affected whenever the temperature around it changes. Why does this happen? The kinetic theory of matter explains all of this. You have learned that matter is made up of atoms, molecules, or ions. To understand the kinetic theory of matter, you must learn two things about these particles. One is that they are usually always moving, and the second is that their motion is affected by temperature, such that they move faster at higher temperatures and slower at lower temperatures. And how fast the atoms or molecules are moving determines the nature of the material. If you look at a solid object, such as a bar of iron or an ice cube, there doesn't seem to be much movement in it. But according to the kinetic theory of matter, the atoms or molecules that make them up are actually moving, but this motion is mostly vibratory about a main position. The atoms in a solid move, but they only jiggle or vibrate at a fixed position. Even within an object, they do not change position as physicists say, they do not translate. But what happens when the temperature rises is that they absorb some energy and begin to jiggle and vibrate even faster. And as long as the temperature continues to rise, they will continue to jiggle more and more until they can move out from their fixed positions. This is when they move to another state of matter called the liquid state. The atoms and molecules in liquid can move about or even translate. They are not in a fixed position. But you see, the space in which they can move is limited. And this is because of something we call the cohesive force, or a force of attraction between molecules that holds them closely together. This cohesive force is much stronger between the molecules of solids, holding them so tightly that they cannot move too far from one another. As the molecules get hotter, their movement becomes stronger than this force, and they can move away for some distance, but the force still holds them down and slows them. This is why the molecules of a liquid, although moving, do not scatter about and reduce the size of liquid in the container. At least, that is what they do until the temperature rises and they become gases. Then they start to scatter. In gases, the molecules are so fast that they do not feel the attraction from other molecules. They keep on moving further and further away from each other and seek even more space to occupy. They will try to escape any container that they find themselves in. And for this reason, gases cannot be kept in an open container like liquids. You can also understand why an open container of liquid left in a hot, dry place for a while would eventually reduce in volume. Why is that? Because some of the molecules have escaped the container. If it is a really smelly liquid, you can perceive the smell of some of the molecules that have escaped in the room. Like when you walk into the kitchen and your mom is cooking. Now, all of these are explained by the kinetic theory of matter, which I have just discussed. The theory has two main statements, and you should remember them and state them this way. One, matter is made up of particles that have kinetic energy. This simply means that the atoms and molecules that make up matter are always moving, either jiggling at a fixed point or moving about. Two, the kinetic energy of these particles increase with temperature. This means that the molecules and atoms move about more freely as they get hotter around the atom. You're going to learn a lot of things in chemistry, but this is one lesson you can understand or experience for yourself. When you see steam escaping a kettle, you can understand what is happening at a molecular level using the kinetic theory of matter. So if someone asks you why his ice cream melted on a hot day, You can tell him the kinetic energy of the molecules in the ice cream increased so much that the ice cream could not remain solid. Or you simply say that the ice has melted, especially if your student is not a science student. That sounds much simpler. In the next lesson, we will discuss the behavior of solids, liquids, and gases which you normally experience using what you have learned about the kinetic theory. See you then.